Welcome to the series of Essentials in Mathematical Methods series. In this series, we will be going through core concepts in mathematical methods and core techniques that derive from those concepts at a very rapid pace. We will only be showing several examples just to demonstrate how the concepts can be used to produce quite difficult questions. As the first video, we shall consider the foundation of methods, which is functions. If I ask you, what is a function? Or what is function? What's your answer? Is it, say, y equals x, or maybe the graph that looks something like this? They are examples of functions or a graph of a function, but they are not the definition of a function. Fundamentally, a function is a rule which assigns each value of x in x exactly one value in the corresponding set y, where this assigning value is called fx equal to y. The sets x and y have special name. X is called the domain of f, and y is called the codomain. A function has another attribute, which is called the range or image, which is the set of all values y in the codomain y that is reachable by this map from x. Clearly, this is the domain, this is the image, and this is the codomain. Importantly, the range or image may not cover the set of all y, or the set of all the codomain. And that's why, in general, the range is different to the codomain. If f from x to y is a function, its graph is the subset of xy defined by xy, where y equals to fx, or simply x fx. A graph of a function could look like this, but cannot look like this. This is what we call the vertical line test. A relationship f is functional if and only if fx has a unique assigned value in y. Whereas in this case, a particular value x gets assigned to several different values. In the sense that if I pass a vertical line through this graph, the vertical line will intersect this relation several times. This concept of having a vertical line and moving through the relation, the domain of the relation, to see how many intersections to get, is called the vertical line test. Enough on general and foundations of functions. Let's turn to functions in methods. Functions in methods will always be written as f domain to the codomain, where the codomain is always just r, followed by the rule of the function. So this is what we call the functional notation, and hopefully now you understand it more clearly. It's really just showing the domain to the codomain and then the rule. We need this notation because the function need a domain, need a codomain, and the rule. Particularly important is that you will need to know how to find the domain of a given function, which is often implied from the rule. Also, you will need to be able to find the range of the function.